Hi, the Nano Pi M4 has been out for some time now. However, this is one SBC I haven't actually gotten around to testing yet. So what makes this board so special? Let's find out. And yes, this video is being sponsored by JLC PCB, who provide all my PCBs. They can produce 1 to 6 layer boards from 0.4 to 2mm thickness, track widths down to 3.5mm, via drill size down to 0.2mm, and can handle BGAs, control impedance, cutouts, gold fingers, and even offer a panelization service. You can pick up 5 PCBs for only $2 in any colour, all manufactured within 24 hours. And if you haven't used them before, don't forget to claim your $20 shipping coupon off your first order. Click on the link in the description below to check them out. So over the last 3 years I've been given quite a few SBCs to review, but there's times when I just go off and buy them myself. The Nano Pi M4 was one such board, and it set me back around 93 kangaroo bucks. So what have the friendly guys given us on this SBC? Starting from the top right, working clockwise. 4 USB 3.0 ports, gigabit Ethernet, RTC header, mic header, audio jack, eMMC socket, HDMI, USB Type-C. Tucked underneath there's an SD slot and also MIPI CSI2 and MIPI CSI1 headers. Not quite compatible Raspberry Pi GPIO header, and a second header with SATA lines broken out. On the semi side we have a bunch of ESD protection ICs, even more ESD protection, and a ViaTech 4-port USB 3.1 hub, supporting up to 2.4 amps per port, but looking at the datasheet it seems like Friendly Arm haven't allowed for this on the power side. 1/2 of the 2GB DDR3 RAM, but you can also get 4 gigs. MOSFET controlling power to the RAM when in sleep mode. Yeah, even more ESD protection. DC to DC converter for the GPU, accessible over RTC. As I mentioned in my Nano Pi Neo 4 review, all the Friendly Arm components have identical part numbers, so U38 is the same on that SBC. D38 is more ESD protection. There's also the AP6356 Wi-Fi and Bluetooth module. U13 is a small 3.3 to 3 volt LDO regulator from RickTech, and a few more regulators splattered around the place. U36 provides 1 volt power to one of the MIPI CSI headers, and U9 is another RickTech DC step down providing 0.9 volts to the SOC. U123 is another regulator for the second MIPI CSI. Q3 is a MOSFET controlling 5 volt power to the SOC via the PMIC. And an interesting way of mounting LEDs, but hey, it works. U37 is a DC buck converter providing 5 volts for the SOC, and a bucket load of 0201 SMDs. There's not a heck of a lot of action on the top side. However, on the flip side we have Q44, yeah, another MOSFET, and even more of the little buggers. U94 is a 2-channel logic level converter from TI that I am using on my Works UPS boards. This provides translation from the SOC's 1.8 volts to 3.3 volts on their GPIO header for I2C. U110 is yet another 5 volt to 3.3 volt DC buck converter. U35 is another LDO providing the 0.9 volt juice for the SOC. U11 is another DC buck converter providing power for the SOC's GPIOs. And yes, there's yet more ESD protection. And U28 is a programmable USB Type-C controller with PD functionality. We've seen this one before as well on other Friendly Arm boards. U2 is yet another LDO from RickTech. Heck, these guys are everywhere. F8 is an SMD polyfuse. And here we have the ALC 5651 audio codec. It's a nice little chip. And U19 is the gigabit Ethernet driver. These semis are as common as a plumber's crack. Yep, more ESD protection. And more SMDs. Actually, I've forgotten why I took these photos, but hey, there you go, more SMDs. U41 provides power control over the USB ports. And here we have the inescapable RK808 PMIC. It's big because it does lots of stuff. Really, you can't get away from having this on board when using any of the Rock chip socks. U101 is another USB PD controller. And here's yet another RT9193. This actually makes it the 5th we've seen on this board. And yeah, not sure why I took this photo either. I'm sure it'll come to me. So before I get started on my tests, I need to whack on the default heatsink. If you've watched any of my other review videos, I often use my Uber heatsink as I found that it performs the best out of any I've used. It's clunky, but you know, it gets the job done. Ideally, I shouldn't use this blue sticky thing because it doesn't transfer heat well enough. But since I've already done a swag of benchmarks on the RK3399 in a previous video, I won't be repeating them here. When you're screwing up the heatsink to the PCB, always make sure to alternate the tightening up of the screws. Doing this avoids applying any torsion forces to the PCB. I also bought an eMMC module that I'll be using to load a couple of operating systems, just to see where they are at now. Then there's the Wi-Fi and Bluetooth antennas. I won't really be testing them in this video, but we all know they work, and it's always good to add them anyway. Then we have HDMI, Ethernet, keyboard and mouse. And hang on, before we add the juice, I will certainly be monitoring power consumption on this little baby with my handy USB power logger. As you'll find out later, this SBC has some pretty decent low power options. Okay, now that we have everything all connected up, time for the firmware. I downloaded Friendly Arm's official M4 releases. Friendly Desktop Bionic for eMMC, Android 8 for eMMC, SD-based Friendly Desktop, and also using their eFlasher. One of the biggest issues with SBCs that have eMMC on board is having to update the firmware on them. For some reason, SBC companies just don't seem to get it right and make it really difficult for you. However, if you want a very simple and easy way to update your firmware, then Friendly Arm provide their eFlasher. This is essentially an SD bootable image that contains an OS image as well, and a small program that flashes this to the eMMC. It is really dead easy, and if you're someone who never reads instructions properly in the first place, like me, you actually can't go wrong with it. Once burnt, chuck it into the SD slot. Unfortunately, this is one of those missile-based SD slots. You know, the ones that blast your SD card across the room and you have to spend a couple of hours trying to find it. Next, just power up the board and you'll be greeted with the eFlasher screen. The eFlasher allows you to easily back up and restore eMMC-based firmware. And if you have a USB drive handy, you can back up your current firmware to that. Nice. All they need to come out with is a USB bootable eFlasher and we can kiss the old SD card goodbye. Once it's finished, power off and remove the SD card and reapply power. Since it's an Android image, the first boot up, it'll do a bit of fluffing around and eventually get to your Android desktop thingy. Do you call it a desktop? I don't know. Whatever. So poking around, it's pretty obvious that Friendly Arm are one of the best at delivering software that works. And they even have support out of the box for accessing the RTC-based low power modes. Nice. With this, you can set a time to wake up and it'll sit there counting down. If you click on power off, it'll shut down, of course, and it'll power back up again when the timer expires. This is the first SBC I've seen providing this functionality working out of the box. When I pushed the SBC into sleep mode, the power consumption went so low that the USB power logger had trouble ranging, as it can only measure down to 100 microamps. So this board can be pushed into some pretty extreme sleep modes. Nice. You also have access to a watchdog, which is essentially something you need to ensure reboots happen properly when an application hangs. And you also have access to GPIOs. Quite a few companies have this option on Android, but none have managed to provide it working out of the box. So out came my blue LED. Holy cow, Batman, works. Is there anything that doesn't work? So let's try playing a video. I loaded up Friendly Arm's 4K demo video onto a USB flash drive, which played pretty smoothly. I didn't see any jittering or dropouts. For any vegetarians out there, I'm sorry, I apologise, but every time I see this bit of the video, I get really hungry. So this 4K video is being downsampled to 1080p. What does it look like on a 4K screen? Unfortunately, I don't have a 4K video recorder, so you'll have to make do with a shaky handheld shot of my son's 4K TV. So the video is smooth and responsive. No complaints here. Alright, so enough of Android. Let's get into an OS that the $6 million man would be proud of. This time with Ubuntu Bionic. Actually, it was Friendly Arm's modified version, but hey, the same thing. I followed the same process as before, burning the whole shebang to SD card, booting, and reflashing the eMMC with the image. Then shut down, took the SD card out, and powered back up again. Easy. So I thought I'd try a few subjective tests just to see the overall desktop experience. It was all pretty snappy, with Chromium loading up my YouTube channel and playing a video without issue. But YouTube will scale the video down depending on a lot of factors. The demo video that's included on the OS image had a pretty snappy playback. The fact that they included a video shows that they have spent a fair amount of time making sure it does actually work. Next, the 4K demo video that I have on USB flash drive. I wonder how this will go. Holy cow, I'm getting hungry again. So yeah, this board has no issues at all with a 4K video. Now I know that the Friendly Arm guys support Ambient financially. This is a big win all round for everyone, because not only do Friendly Arm end up with better software for their SBCs, but you get a much more stable platform. You can see this when you log into the OS. It has a familiar feel to it, as it's just Ambient rebadged. So one thing I didn't try last time is OpenCV. Friendly Arm provide a GitHub repo that gets you up and running pretty quickly. And building the examples was straightforward. And so was running the examples, like smile detection. Okay, alright, so that demo didn't quite work that well, but the whole OpenCV API was working without issue. Now I did run into an issue with my 1080p webcam. It would lock up completely and vanish off the bus. But this is actually an issue with the webcam rather than anything on the M4. I actually have the same issue on a standard Linux desktop. Switching to a lower res, better supported camera worked without issue. So with all that mucking around, what did the power consumption look like? I saw a peak of 3.2 amps with an average of 663 milliamps. This is in line with all the other RK3399 based SBCs out there, so no surprise. Okay, so we had the capability to use the onboard RTC to wake up the main SOC from sleep mode on Android. Can we do it on Linux? Turns out there is an executable called RTC Wake, which allows you to both set a wake up time and push the SOC into several sleep modes. The Nano Pi M4 supports only a handful of modes. Freeze mode freezes all processes, suspends devices, allowing a faster wake up time from sleep, but still consumes a fair amount of juice. I saw this mode getting down to 345 milliamps, peaking at 431 milliamps. Not that low, but as you can see from the graph, there were no processors pulling the CPU load high. When the SBC woke from freeze mode, there was a sudden current surge of 1.2 amps, lasting for around 0.8 seconds. This is to be expected as processors and devices start back up again, and something to bear in mind when using this mode. Mem mode is essentially the same, but also suspends to RAM, giving you further reduction in power consumption. However, this mode never really worked on the M4, for whatever reason. Then there's off mode, which speaks for itself really. As I mentioned before, my power logger couldn't measure down below 100 microamps, but it does indeed work well. Of course, starting back up again from the off state saw the board hit a peak current draw of 1.6 amps with an average of 715 milliamps. This all lasted around 20.3 seconds and then settled down to its idle current of around 550 milliamps. So enough of mucking around with power. What about GPIOs? What works and what doesn't? The OS image comes with the Wiring Pi tools pre-installed and pre-configured. There's 6 I2C buses visible from the SOC with a bunch of devices visible on each of them. Of course, the last bus is the HDMI port, which always hangs because of my Elgato HDMI recorder. Pretty much all the I2C devices have kernel drivers. Most of them are related to power management, but there's also USB Type-C control and MIPI CSI ports. You can query all the voltage levels pretty easily with a simple script. There are 4 I2C buses available on GPIO pins. 2 of them are at 3.3 volt logic levels, while the third one is running 1.8 volt logic levels. And the 4th is on the MIPI CSI connector, which also runs 1.8 volts. So can you actually access I2C? My handy dandy lux sensor will be good enough for this. Yep, looks pretty good. Okay, so now we've tried out the official Friendly Arm distro. Let's try out Ambient. The reason for this is to check out the latest 5.0 series kernel, which has massive improvements for handling GPIOs. Similar process to before. Burn to SD, insert, power up. It goes through its fiddly bits for a while and you get a plain login. The first time you log into Ambient, it prompts you to change the root password, set up a new account, and then it starts the desktop. Okay, so first up I should point out that currently the stock Ambient release doesn't have the RK-MPP acceleration built in by default, but you can actually add it in later. To show you what difference this makes, here's that same 4K demo video played back on stock Ambient. Not only is it not scaled properly, but it's as slow as a wet week, with tons of frames dropped. Scaling doesn't make any difference either, which is to be expected. And VLC sort of, okay, forget it. So if you head on over to the Ambient forums, you can pick up a script that fixes everything for you, thanks to JMCC. Just pull the tarball, extract, and pick your options. And don't forget to disable the window manager compositing. If you saw my NanoPi Neo 4 video, you'll see what happens if you don't. Then reboot. However, after all these changes, make sure to pick up the right version of Media Player. Otherwise, you'll get similar laggy results. But not only that, it'll often just hang and crash. Using the correct RK-MPP enabled Media Player gives you what you want. Oh, dead chook. Or is it a duck? Hang on, give me a minute. This is making me hungry. Alright, so where was I? Oh, okay. So make sure that you use an RK-MPP enabled media player. For instance, using an unmodified VLC will give you this pretty funky result. Now I was interested to see just how much CPU playing a 4K video chews up. So making sure all CPUs are set to on-demand mode and let it idle for a couple of minutes, I started up the 4K video playing in an endless loop. So the temperature rose from a 36 degrees Celsius starting point to a maximum of 53. Still not a concern, and bear in mind that this board had no fan on it. And the power consumption? Heck, it just flatlined at 550 milliamps, with the occasional blips on the radar. Meanwhile, that chook is still being massacred in the background. Alright, pretty decent result. So before moving on to upgrading the kernel, let's have a quick squiz at what else we have on Ambient. All the PMIC voltage levels are accessible, of course. I2C is there with a bunch of I2C devices. And yeah, all the GPIOs work. Okay, no problem there. Alright, let's upgrade the kernel. This is pretty easy, just run Ambient config and first switch to nightly builds. Once it's finished fluffing around, reboot. Then run Ambient config again to install the latest kernel. Then reboot. Now that you have kernel 5 installed, you can use LibGPIO. There's a number of tools provided in this package. GPIO detect will show up all the GPIO chips available on the system. GPIO info will show up all the details of each GPIO line. GPIO get will make the GPIO an input and read the current state. GPIO mon will actively monitor and return the state of the GPIO. And GPIO set will make the GPIO an output, and you can set it to high or low. You can also make the GPIO lines an active low, which essentially inverts the GPIO. While I was testing out GPIO inputs, I noticed something pretty weird. I was trying to pull up a GPIO pin by attaching one end of a jumper to 3.3 volts and the other to a GPIO pin. It sort of worked, but then the board crashed and rebooted. Weird. Looking at the schematic, there seems to be a bit of a mistake. The GPIOs marked 3.0 volt signals aren't actually correct. The pin I was toggling, I2C3_SDA, feeds directly into the RK3399 without a logic level converter. In fact, a lot of these signals are incorrectly labelled. However, even after backfeeding 3.3 volts into the 1.8 volt line, nothing was damaged. So since the GPIO lines all have pull-up resistors on them, just pull the GPIO line down to ground and you'll be okay. So there you go. The Nano Pi M4 is a pretty decent board where everything just works. And I was having real trouble trying to find anything wrong with the board. The Friendly Arm guys are a good example of a company doing things right. All their products are now pretty mature and you can't go wrong with any of the boards. So if you're looking for a decent alternative to the Raspberry Pi, check them out. Now normally I run through a battery of Phoronix tests in my reviews, but I didn't do it this time because I didn't find much difference between the last three RK3399 based SBCs. However, if you'd like me to run any particular test, or if you think I've forgotten anything, then comment below. So I think that about wraps it up. Yeah, okay. Don't forget to thumbs up and subscribe. Thanks for watching, and see you next week.